Welcome back, guys. Today we're going to look at yet another characteristic of matter, and that is something called solubility. But we're going to start by looking at what is a mixture. In the real world, a mixture is a combination of two or more substances that aren't chemically bonded. That means that they are combined, but that you can separate the particles from each other because they are not chemically bonded to make a new substance. Some can be easily separated, while others it takes a little more effort to separate those. And some common examples that you might know of mixtures are chocolate milk, because that's a combination of milk and chocolate, and salads, because that's a combination of lots of different fruits and vegetables. So let's take a look at this little activity about separating some mixtures, and I want to show you that some mixtures are a lot easier to separate than others. The first one that we have is iron fillings and sand. Of course, if you know anything about iron, you know that it's a metal, so it would be magnetic. So I would want to use a magnet, and that would separate out the iron fillings from the sand that is left in the bowl. Another mixture is salt water, because that's a combination of salt in water. If I wanted to separate these out, and you might have done this one by accident at home, I could simply heat the salt water, the water would evaporate, and I would be left with salt crystals in the bottom of my container. The last one I think is really funny, chicken noodle soup. If you want to separate out the mixture of chicken noodle soup, you simply pour it through a strainer, and that separates out your noodles from the soup portion. So let's think about some solutions. A solution is simply when one substance dissolves into another substance. It is still considered a mixture because sometimes it can be separated, but a solution is when one substance dissolves into another substance. For example, Kool-Aid. Kool-Aid, to make your Kool-Aid, you take the Kool-Aid powder and you mix it into water. In this particular example, what is being dissolved is called a solute. The Kool-Aid is the solute. The powder that you put into the water is the solute. The solvent is what the solute is dissolving into. So in this particular example, the solvent would be the water that you're putting your Kool-Aid into. Sometimes substances are considered insoluble. That means that the solute will not dissolve into the solvent. And so I've put a picture here of oil and water, because you might know that if you pour oil into water, the two will not mix. You can stir and shake and stir and shake, and they will appear to combine, but when you let it rest for a while, the two will separate from each other once again. Those are called insoluble. So what kinds of things affect the rate of dissolving, or how fast a solute will dissolve in a solvent? The first is movement or stirring. And I put a picture of chocolate milk here because those of you that have ever made chocolate milk know that you add the chocolate syrup to your milk and you stir it with a spoon. And you may not have ever thought about why you do that, but that's because stirring speeds up how fast the chocolate will dissolve into the milk, or how fast the solute will dissolve into the solvent. So a movement or a stirring is going to speed up the rate of dissolving. The second thing is the size of the particles. So I put a picture of a sugar cube here because a large sugar cube is going to take longer to dissolve in water than this small fine-grained sugar, because there is more surface area for the solvent or the water to have to react with. So the smaller the particle size, the faster it's going to dissolve. The last thing is temperature. And I want you to think about this temperature as how fast it makes the dissolving happen. If you add temperature or add heat to a solution, it's going to make it dissolve a lot faster. And sometimes you might have seen this if you're getting ready to make spaghetti noodles and you put water on the stove and you put salt into it. That salt's going to dissolve a lot faster in the boiling water than it is in plain water. So let's talk a little bit more about solubility because you have to know about this. Solubility is actually a measure of how much solute, and you might remember that that's the solid that is being dissolved, or let's not say solid, let's say the substance, because it won't always be a solid. So that's the solute, and we want to see how much of that can completely dissolve into our solvent, and that is what you're dissolving it into. There is a limit on how much can be dissolved, and we're going to look at that in just a second. All pure substances have the same solubility value or solubility rate at a certain temperature. That means if I took 1 cup of salt and I dissolved it into water, it would dissolve at the same rate as a half of a cup of salt would, as long as I use the same temperature water and the same type of salt. It doesn't matter how much you have, it's going to dissolve at the same rate. So let's take a little look at something called a saturated solution. A saturated solution is defined as a solution that has dissolved all it can at the current temperature. So I'm going to click on this salt, and I want you to watch what happens when we stir. Remember, stirring is one of the things that can speed up solubility or dissolving. Notice that all of the salt particles disappeared. You no longer see them. So let's add another spoonful of salt and stir. As we continue to do this, again, you notice that all of the salt grains have gone away. Watch what happens now. Notice that when we stir, some of the salt grains go away, but some of them do not dissolve. That means that the water or the solution of salt water that we have created has reached the saturated solution level. It can no longer dissolve any more salt granules at the current temperature. Now, I could possibly add heat to this and make it dissolve a little bit more, or I could possibly add more water and that would help dissolve it as well. So I want you to make sure that you understand this. A saturated solution is a solution in which the maximum amount of solute has been dissolved in the given amount of solvent. In other words, a saturated solution means the maximum amount of substance is dissolved in the liquid you're putting it in, and it can no longer dissolve anymore. Okay, so what I would like you to do is, in your science notebook, I would like you to brainstorm for just a second. And I would like you to imagine that I'm giving you the job of thinking about 3 different solutions. Now these 3 solutions can, you could take one that we've already talked about if you would like, but I want you to think about 3 different solutions in the real world. When you think of those 3 different solutions, I want you to make 3 columns on your paper. The first column is going to be what is the name of the solution. The second column is going to be what is the solute, and the third column is going to be solvent. Okay, so here's what it might look like. Let's say that my first solution is going to be a Kool-Aid drink. You might remember that we said the solute in this particular case is the Kool-Aid powder from the little pouch that you buy at the store. The solvent, what you put the Kool-Aid powder into, pretty much, if you want to remember it that way, is water. I don't know about you, but I mix mine in water. So if that makes sense to you, you're going to come up with 3 of those. 3 of those, please. Make sure that you put the name of the solution, the solute, and you identify the solvent as well. I hope that you've enjoyed this lesson. Let me know if you have any questions.